Have you ever wondered about the mystery of the giant? But a hidden force inside this emptiness defies physics. Would you travel across 1 billion light-years of nothingness? This supervoid spans 330 million light-years. If we lived inside it, we wouldn't see other galaxies. Galaxies on the edge are being pulled inward toward nothing. Scientists expected to find thousands of galaxies inside this zone. Instead, dark energy is actively expanding this terrifying cosmic desert. It might eventually consume our entire sector of the universe. That detail becomes important later. This massive cosmic desert spans 300 million light-years. Entire superclusters of galaxies look tiny next to this emptiness. Yet something invisible inside is slowly dragging nearby galaxies inward. Astronomers expected to find absolutely nothing in this dead zone. Instead, they detected a few lonely, strangely distorted galaxies. These isolated galaxies are growing larger than our own Milky Way. It is like finding a thriving metropolis in the Sahara. A concentrated dark matter filament acts as the hidden drain. This invisible structure feeds on everything crossing its dark borders. That detail becomes important later. Galaxies near this supervoid's edge are behaving very strangely. Their stars are being pulled outward by an unseen force. Something inside the empty space is actively warping cosmic gravity. Standard physics cannot explain this massive, one-sided gravitational pull. Instead of pushing matter away, this emptiness acts like suction. Galaxies are literally stretching as they slide toward the abyss. It is like watching a slow-motion cosmic drain at work. The center contains hidden dark matter, clumps driving this acceleration. These lonely survivor galaxies are slowly being stripped of gas. Entire star systems vanish into the dark, leaving no trace. We track the runaway galaxies fleeing toward the void's edge. Something massive is actively pulling these star systems from behind. Their strange alignment hints at a hidden cosmic anchor nearby. Standard gravity cannot explain this synchronized, rapid galactic flight. Oddly, this empty space bends passing starlight like glass. It behaves less like nothingness and more like a drain. Entire clusters are drifting toward one specific dark boundary. That anchor is an invisible dark matter bridge feeding the void. Isolated worlds inside are slowly being stripped of their gas. Next, we must measure the speed of this cosmic theft. Galaxies are drifting away as the void between them expands. Dark energy acts like a cosmic spring pushing everything apart. These regions contain far less matter than the surrounding space. A massive void is actively repelling our own Milky Way. Galaxies near the edge move faster than physics usually predicts. Gravity fights to hold on, but expansion is clearly winning. Some galaxies end up trapped in these lonely, dark regions. But here is the part that defies our current understanding. Invisible dark matter scaffolds hold these voids in perfect shape. Wait until you see what happens when voids eventually collide. Extreme macro close-up of dark matter pulling stars toward edges. Gravity fails here, leaving only a vast, cold, empty expanse. Entire galaxies drift away, seeking shelter in denser cosmic clusters. But there is a strange pressure pushing from the center. Dark energy accelerates this expansion, making the void even larger. It is like a bubble forming in a boiling liquid. Some voids are so massive they defy our standard models. We finally know why the center stays suspiciously empty today. Matter clumps together, leaving these giant holes behind for us. Stay tuned to see what happens when voids finally collide. The Boötes Void is a sphere of nothingness spanning millions. Scientists expected thousands of galaxies, but found only 60 here. Gravity tries to pull matter in, but dark energy pushes. Galaxies cling to the edges like foam on a bubble. Surprisingly, these empty voids contain hidden filaments of dark matter. Dark matter acts as the skeleton holding our universe together. Galaxies are literally migrating away from these vast empty regions. It is the energy density that dictates this strange migration. If Earth were a grain of sand, the void is. Eventually, these voids will dominate the entire map of space. First-person POV, looking through a telescope at dark space. Galaxies are drifting toward this massive, empty, dark gravitational well. It is not a black hole, but something far larger. Empty space actually exerts a strange pressure on surrounding matter. If you enjoy this mystery, please hit that like button. Vast regions of space are actually expanding faster than others. Hit the subscribe button and press the bell icon to get updates. Dark energy pushes the void walls while gravity pulls inward. Our galaxy is currently being pushed away from this region. That detail becomes important later. First-person POV, looking through a telescope at dark patches. Voids act like cosmic bubbles pushing galaxies toward the edges. Even within these voids, faint filaments of dark matter persist. Galaxies are effectively evicted from these regions by dark energy. Strangely, these empty voids actually create the universe's complex structure. Without these voids, the universe would be a uniform soup. Some of these voids span hundreds of millions of light years. We still struggle to map the density inside these gaps. Dark energy is the invisible fuel driving this cosmic expansion. What happens when these voids meet? That's the next chapter. Imagine a sphere 300 million light years across entirely empty. Statistically, this region should contain thousands of massive, bright galaxies. Instead, we find only a handful of lonely, isolated systems. Gravity usually pulls matter into filaments, leaving vast empty bubbles. Yet this void is far too large for standard models. It is like finding a hole where the floor vanished. Dark energy might be carving these gaps between the filaments. Could dark matter be hiding within this seemingly empty space? We are watching the universe stretch into a new shape. Next, we examine the force that might be tearing reality. Massive galaxy clusters accelerate toward the edge of empty space. Matter density plummets as galaxies approach these vast cosmic deserts. Dark matter acts like scaffolding, pushing matter into these fringes. Gravity from surrounding filaments drags galaxies into the void's depth. It turns out these voids are actually growing, not shrinking. Space itself stretches faster inside these voids than anywhere else. Stars dim significantly as they enter the void's cold influence. Dark energy pushes outward, fueling the expansion of these voids. Eventually, the entire universe will become one giant, empty void. That detail becomes important later. Extreme low angle looking up at a spiraling galaxy cluster. Voids are not empty spaces, but active regions of growth. Entire galaxies drift toward these dark centers like falling leaves. Dark matter acts like a giant anchor pulling everything inward. Current models struggle to explain this immense gravitational tug force. Something massive hides behind the veil of our own galaxy. Matter piles up in these zones, creating intense gravitational wells. It is not swallowing galaxies, but organizing our cosmic neighborhood. This structure is simply how the universe builds its skeleton. The facts remain, and the search for truth continues.